All right. Hello, everyone. I love that. It's wonderful. Thank you, Peter, for hosting this again. You are my personal savior.
You're
And
welcome.
welcome, everyone in the chat. And welcome, Colton. Welcome, Dr. Rana. Great to have you guys back.
Thank you.
Colton, have you actually been on my channel at this point?
I don't think so.
Oh, well, welcome, first timer. Now you get to be on. On my channel at this point.
I don't think so.
Today we're going to talk about a number of different issues, including dinosaur soft tissue and young Earth creationism, because of course those two topics go together, and probably radioactive decay and rapid plate tectonics. So a bunch of fun stuff. Hello, TD Lane and Scarlet Eyes. Hello, welcome. So I suppose first this conversation kind of came about in part because of I dropped a line to you, Dr. Rana, about something that you had already heard of, but something that was new to me, which Colton was aware of and informed me on. But we'll get to that and all the juicy details behind the Triceratops horn and Mark Armitage. So, Dr. Rana, you have actually written a whole book on dinosaur soft tissue and how it relates to the age of the Earth.
Yeah, I have. And by the way, thanks again for inviting me to hang out with you guys.
Yeah.
I'm as in the spirit of being completely forthright, I'm an old Earth creationist, and so the three of us would probably disagree with some of my perspectives. But nevertheless, I do hold to an old Earth viewpoint, and as part of that perspective and part of the work that I do for the organization, I'm part of Reasons to Believe. Young Earth, old Earth conversation is always something that is in the foreground. I actually find that conversation, frankly, tedious, but nevertheless, it's a conversation that people within the church, particularly evangelicals and fundamentalist Christians, really find to be an important conversation. And I've been over the years asked repeatedly about the young Earth claim that there are soft tissue remnants within fossil remains, not just dinosaurs, but other fossils. And, eventually reached the point where I thought, well, maybe I ought to actually roll up my sleeves and do a little bit of work offering a response to that. And so that led to the book, Dinosaur Blood in the Age of the Earth. But in the process of writing the book, I actually became really quite fascinated with that particular area of paleontology. And so in and of itself, it's just fascinating to me that there are these soft tissue remnants that do persist, at least in some fossil remains. And this is really a boon for paleontologists trying to get a glimpse into the history of life on Earth and into the biology of past organisms, because it does give you a molecular picture on what these organisms were like. And so it's in and of itself, it's fascinating work. And so I love discussing the whole issue of soft tissue remnants in fossils. And as a biochemist, it's particularly intriguing to me, just simply how can you explain mechanistically how these types of materials can persist in the fossil record. And in spite of the claims of and the assertions of my young Earth creationist brothers and sisters, I think there's very good explanations that we can bring to the table as to why these soft tissue materials persist. It's not some kind of mystery. It's not outside the bounds of scientific credulity whatsoever. And so that's kind of my involvement in this. And as you mentioned, you sent me a little tweet or a message over Twitter asking me if I had heard about the claims regarding the Triceratops horn that Mark Armitage has discovered and analyzed. And I had heard some inklings of it, but I didn't have anything that was, that I felt like I could credibly cite to bring that point to bear. So that's how this whole conversation started, as you pointed out. So thanks for inviting me.
Yeah, absolutely. And that's actually a great lead in for Colton, because I had never heard of that either. My thinking originally with the Armitage Triceratops whole issue, incident, whatever, was just, okay, we have another paleontologist who has found soft tissue in a dinosaur fossil. At this point, no big deal. It's been done by Schweitzer with the Tyrannosaur and with the Tarbosaurus and Brachylophosaurus and a few other, even some Mesozoic turtles. And that was before I met Colton. So I really want, or Colton, you haven't yet had a chance on this channel to expound on that. I did send Dr. Rana the article, or one of the articles that you had written on this on Reddit, and so please do tell us your perspective on the Armitage Triceratops horn, if you will.
Yeah, so while I don't know for certain that it isn't a Triceratops horn, I have a lot of suspicions, and this mostly comes down to a lot of the faulty methodology in his paper. For example, he got it from the Glendive region, and he claims that it was found on some well-known dinosaur range. But his paper doesn't actually give an exact location. He uses a old range township style that, as far as I know, hasn't been used as like a GPS coordinate system since the 1950s. It's completely out of date to use, and it's very good for hiding where you specifically get it from. His paper also didn't have any sort of stratigraphic analysis done to tell us what the strata this thing was found in was like. And the problem is there are Ice Age deposits in the Glendive area, which leads to the possibility that this thing could be a misidentified Ice Age bison horn. And I had heard some ramblings about this too, but I decided to really actually look into it. And I contacted this archaeologist, Gary Hurd. He's posted on Talk Origins about soft tissue in general back in like 2005. And he was one of those people who was really suspicious about this thing's identity. And it turns out that although the shape of Triceratops and bison horns both vary quite considerably, the general morphology of Armitage's horn did look consistent with a horn of bison latifrons, which, I mean, its size, its shape, its curvature, its thickness, it looked pretty close from the pictures that he had. And one of the things that I found particularly concerning was that when I looked in his paper, Armitage described the horn as being about 58 centimeters in length, which is roughly 22 inches, I believe, give or take. But then you look at the picture he provided in his paper, and it's held next to a meter stick, and it is clearly 34 to 36 at least. And then he claims elsewhere, both in videos responding to me and Jackson, and also a few like Adventist news groups online, he's claimed this horn to be upwards of 48 inches long. And if his horn really was 48, first of all, I have to ask, why didn't you put that length in the paper? Why did you cut it almost in half when you reported it? But 48 inches would not be characteristic of a Triceratops. As far as I know, their horns only reach about 3 feet in length max. But bison latifrons horns have been known to reach upwards of 44 to 46 inches in length. So again, it depends on which measurement is accurate, because it's clearly not the one he listed in his paper. And from the pictures I've seen, I don't think it's as big as he claimed it was either. So it's really kind of a messy situation trying to analyze the identity of this thing. And the fact that there's no stratigraphic analysis, we don't have an actual accurate location given. We have these mysterious claims about size. The whole thing just feels fishy to me. Yeah, so I guess that's what I have so far.
What, Dr. Rana, what are your thoughts on that?
Yeah, in terms of really a question for Colton, if I may. The importance of the stratigraphic analysis is that if it's in a particular layer, then it most likely is a bison horn, right? Is that
Yeah.
kind of your point?
Yeah, that's one of the issues I have with it, because if you've got Ice Age strata in the area, like around that same town, then you need to be giving a competent stratigraphic analysis saying, I got it from this specific unit in this specific location, and he didn't provide that. So, and if you look at any other paleontology papers, that's typically something they provide.
I see.
So that's kind of
Yeah.
a problem.
Yeah, that's all of that is very, very strange. It's strange that in addition, he said he destroyed the horn without making a cast after
Yeah, he did that too.
collecting the samples. Yeah.
So aside from some pictures, we don't really have anything to analyze. We don't like have a cast of the fossil we can send off to some expert and say, "Hey, do you know what this thing is?" So it's little
Yeah.
bit strange.
Yeah, no, nothing for anyone to look at after
But
collecting.
one of the things that concerned me also was that some local creationists on YouTube brought this issue up to Armitage, and his response was to claim that it doesn't seem like an accurate comparison because, as far as he knew, bison horns tend to be hollow keratin sheaths, which he's thinking of like the typical kind of hollow sheath you'd see like Vikings, the stereotypical like horn they have. And that's not true because bison horns, especially bison latifrons, have a bone core in the middle. And that's where the 44-inch cores are known from. That's not counting the keratin, which God knows how big those things were, but just the bone itself could reach up to the size that Armitage is claiming. And I don't know if maybe he misspoke and meant that like the inside of the horn core was supposed to be hollow. But as far as I've been able to tell, that's not characteristic of bison horns in general. In fact, when I think, what was his name? Marsh, one of the guys who first discovered Triceratops, he originally thought these things were bison horns when they weren't found attached to a skull because their physical characteristics are almost identical. They have very close size and shape, and they both have a hollow lower half because the horn, when it connects to the skull, actually has a hollow piece going into the sinus cavities on both Triceratops and bison. So morphologically, these things are very close, and that just kind of leads to the question of why was this thing not properly analyzed by an expert in identification, and because the paper doesn't even give any real justification for the identification of it. They just say, oh, its morphology is consistent, and they don't go into detail about it.
Yeah, all very strange, very fishy. So far I haven't seen like a whole lot of stuff from Armitage responding to this, but I also hadn't even heard that until just recently.
Aside from his video response,
Dr. Rana, you have had some.
Oh, go ahead.
Yeah, he did the one with what's his name?
Standing for Truth.
You're talking about the one a couple weeks ago, right?
Yeah.
Yeah, that's right. Fun times. But Dr. Rana, you have actually had interactions with Armitage, haven't you?
Oh, yeah.
I've had limited
Or back and forth?
interactions with him, I am not one to shy away from engaging criticism of my ideas. I will engage,
Sure,
those criticisms, and yet, with respect to the book Dinosaur Blood and the Age of the Earth, and just even things that I've written beyond the book, after the book was published, blog articles and things like that, updating, advances in terms of mechanistically trying to understand, again, how soft tissue can be preserved. I have engaged young Earth creationists who've actually come to the table with real technical challenges or raising technical points to the points that I would raise in my book. With Armitage has engaged the content of Dinosaur Blood and the Age of the Earth, but his presentation of the content in the book is so distorted and is so it's so horribly distorted, where he's completely misrepresenting contents in the book, that I've actually decided it's not, frankly, worth engaging him, because I don't want to get into a situation where, as we are right now, where I'm basically saying, look, you're not even properly representing the book. I mean, I do talk about the work that Armitage has done, and Jackson, like you, I acknowledge it as at the time, taking it at face value, saying it looks like, this guy Mark Armitage has discovered, osteocytes, or at least the remnants of osteocytes in a Triceratops horn. I cited, the publication that he where he reported it in a microscopy journal, as you point out. Just basically leave it at that. Say, hey, this is among the body of work that that's been reported of soft tissue remnants in all kinds of organisms, not just simply dinosaurs. And so he's accused me of misrepresenting his work, or ridiculing him and things like that. And I've gone through the book over and over again just to make sure that I didn't write anything that could be misconstrued in that way. One of the things that I do in the book, just as a way to have a little bit of fun, is I talk about Ripley's Believe It or Not, right? Because this discovery of soft tissue remnants and fossils is kind of a believe it or not discovery.
I liked those sections of your book.
Thank you. They made
it a very easy read.
It meant to have a little bit of fun with this topic, because it is a fascinating topic, and we should have fun with science, I think. And so he accused me of claiming all young Earth creationists are charlatans, and it's like, wait a minute, Robert Ripley to me is actually somebody that I treat with quite a bit of sympathy and honor in the book. I think he was a genius when it came to entertainment, and so I don't see him as a Barnum Bailey type of figure, right, or a charlatan. So in other words, it just felt like there was no way to constructively engage in any criticism that Armitage would bring to bear that actually may be worth responding to, because it's so much doctored in this personal assault and this personal attack against me.
That was the impression I got when I watched his video responses to you, and just the way he kept insulting you and Hugh Ross, calling you guys huge wrong and fuzzy frog, and it's like, dude, grow up. Come on. You're supposed to be a Christian and engaging the data in an honest way that would glorify God, and that's the way you're gonna come about it? That was off-putting to me alone. Not just the fact that I also went through, to the best of my ability, his responses to you, and I didn't feel they held very much water. But I suppose that actually does bring up another thing that I thought was interesting, because if I recall correctly, in your book, you did bring up how he had his horn carbon-14 dated, right?
I did, yes.
Did you see the actual lab report on that? Because this is another detail that kind of makes me iffy about his work in general.
No, the approach that I didn't see the lab report, to answer your question.
Yeah.
And the approach that I took in the book was to try to find the most sophisticated presentation of the young Earth argument for soft tissue being evidence for an Earth that's 6,000 years old or 10,000 years old. And to me, I think the one person that has done the most responsible work, or the two people, it would be Kevin Anderson, who's a biochemist, as well as Brian Thomas. So I really took their work and I engaged their work. And when it came to things like the report of a carbon-14 in the dinosaur fossils, not only the Triceratops horn, but other dinosaur fossils, I just took the results at face value without even looking at the methodology that they employed. And even then, the amount of carbon-14 that they are detecting is essentially within the baseline, within the noise of the methodology, right?
Yeah.
Well, here's the thing. It's not just that. With Brian Thomas's paper specifically, I actually sent that to what was his name? I'm pulling a blank, Jax. Do you remember the guy who did the diamonds paper? Irvin Taylor, that's his name.
Oh,
I sent his Brian Thomas's results to Irvin Taylor, who he died, I think, last December. And he reviewed it, and he wasn't impressed because you had like fossil. You had one of their samples where they dated two pieces of it from different parts of the bone, and they were dating 8,000 years apart. And Taylor was like, "Yeah, that is a surefire sign of contamination in the fossils because a authentic 14 carbon is even throughout a bone. You don't get an 8,000 year difference between two pieces unless something was screwed up." But that's really a side issue because with Armitage's report specifically, what kind of made me iffy was he keeps claiming to have found a ton of collagen in this thing, but the sample the lab got, they explicitly told him in the report they could not extract any collagen from it. Yet he's claiming to find giant sheets of it, and that just those two things don't really seem to square together very well. So I don't know what's really going on there. I don't know if he's maybe misidentifying something that isn't collagen, or it would be weird for them to send
Oprah
a piece
would
that.
say. To
Yeah,
quote
I don't.
Oprah, what is the truth?
Yeah.
Well, you know, the thing is I have a very simple diagram in the book on that when it comes to the carbon-14 in the dinosaur or in the fossil remains of dinosaurs, and particularly Armitage's Triceratops horn, or quote unquote Triceratops horn. And what I point out is that, you know, if that you would expect anywhere between 45% if the horn was 6,000 years old to 72% if it was 3,000 years old of the original carbon-14. And the fact that they're getting 1% right away is a clue that even though you're reporting carbon-14, you're not reporting the levels that you should detect if indeed the sample is actually 3,000 years old or 6,000 years old.
Yeah.
So it's a, you know, even if you take the results at face value and you just assume that they did everything impeccably, you're still getting a result that doesn't fit their model, right, whatsoever.
Which is why I believe, if I remember the literature correctly, their whole way to get around that is to claim that because there was so much biomass in the pre-flood world, it essentially diluted the 14 carbon to 12 carbon ratio. So that way things would date consistently older than they would with our ratios now. And I remember seeing a response by that from Kirk Birchie, who did the Talk Origins thing on like the coal and diamonds. And he laid out pretty clear that, well, if that's the case, then there should be a very narrow range of dates that all this pre-flood biomass gives. But instead, you've got such a wide scatter of dates that is completely consistent with contamination, but is not consistent with one biomass from one period in time that all got buried. So even then, that kind of ad hoc rationalization of, oh, well, the ratio is different doesn't even really match up with what we would expect.
Yeah. I think it is important in case we have any creationists watch or watching currently to point out that what exactly the soft tissue is that is being found, and really how much of it there actually is. Because if you listen to people like Eric Hovind, he thinks there's like blood being found in it.
You know, bringing up the amounts,
Dr. Rana, is not the case.
Bringing up the amounts, that was actually a point, Dr. Rana, in your book that when I was reading it, I actually had not thought of, and I was after when you brought it up, I was like, wow, how did I not think of that before? I forgot to take into account, man, these were big animals, and so there was just a lot more stuff left in them, like in terms of collagen, just by sheer volume compared to, say, like a human bone, just because the bones were so massive, which is going to extend how long you think it's going to be around.
Yeah. Well, you know, and I think it's important to point out too that you know what people are discovering. This is something that that really drives me nuts, to be quite frank. Is that when you hear young Earth creationists talk about these finds, they're describing it as if people are, you know, are discovering things like collagen molecules that are completely intact, right? And it's not. What they're discovering are these fragments of collagen molecules, and they're using antibody binding primarily as the way to detect collagen. And these antibodies are binding to very, very small portions of the collagen molecule. And so if you have fragments of collagen there, you're going to get binding just as you would get binding to the intact molecule, because again, you're binding to very, very small regions. So if fragments are present, you're going to get binding. The signal and the strength of the signal is probably going to be different if you're doing antibody binding with fragments versus the intact molecule. But or the recent claim of DNA remnants in this duck-billed platypus.
That was the hadrosaur, wasn't it?
Yeah. Thank you.
Hadrosaur.
Yeah. Thanks.
I'm very skeptical of that one.
Well, the thing is, I'm sympathetic to the fact that maybe there actually could be, DNA fragments in that specimen, simply because it's an extremely well preserved system where you're dealing with, cartilaginous tissue right at the growth plate, where you have these chondrocytes that are consuming, metabolizing at a very high rate because they're going through rapid cell division, hyperproliferation of the cells, which is going to consume oxygen in the local environment. But because they are rapidly dividing, Schweitzer claims that she was seeing not only outlines of the nucleus, but what looked like what were chromosomal remnants in there. So if you got this tightly packed structure in an oxygen depleted environment, you could actually have some DNA preserved, even if that DNA was heavily fragmented and damaged, because the dyes that are binding to the DNA are intercalating in between the bases. And all you need is about something that's about 6 base pairs in size to get the dye to bind. So you can have heavily fragmented DNA that's heavily damaged, where you just still have some base stacking going on, and you're going to get dye binding. And
I remember reading that paper, and one thing that I thought was funny was the creationist who brought it to my attention, or the young Earth creationist rather, brought it to my attention. He had missed a part in there where they described the actual locality where the fossils were found and the distribution of these bones. And they were explicit that it looks like these things were not buried rapidly. And so that was kind of something to be like, well, hey, how does this fit the chaotic flood burial thing then, if it looks like they were disarticulated for some time? But another thing that they mentioned in that paper that I thought was really cool was apparently there had been claims of chromosomal microstructures that had been preserved in a fern. It was one of their references.
Oh,
and
yes.
When I read that, it looked like it was like the case of the structure of the chromosome being preserved, even though the molecule wasn't. Like there was like a almost a microscopic precipitation of calcite, if I understand it correctly.
Yeah.
So I tried to explain to this guy that, sure, you may have what looks like a chromosome, but that doesn't mean that an entire chromosome of DNA has been preserved. It looks like it's a preserved microstructure, which may have some very fragmented remnants preserved within it.
Yes. That's
okay.
That's,
so I'm correct there. Okay.
Yeah, I mean that's very well stated, and I think even when you're talking about these cellular structures that are preserved, it's the morphology that's preserved, right? Where you could have, again, trace amounts of organic materials associated with it, and the types of materials you're seeing, things like heme, or collagen or keratins in some instances, or chitin, these are incredibly durable materials that are heavily cross-linked or highly aromatic, which are, characteristics, molecularly speaking, that impart robustness to a chemical structure. So you're seeing preserved what you would expect to be preserved based on the structural robustness of those particular systems. And again, it's evident that they've undergone chemical changes. That again, it's remnants that are being preserved in these morphological structures that, are derived from the original material, but are not the original cells or what have you.
I guess there was actually a question I wanted to ask you, because this is like an update after your book was published. I believe in 2018 they found a new mechanism for preservation that was basically like almost turning these structures into a sort of natural plastic, like a polymer of some type. I just wanted to know what your thoughts were on that.
Yeah, well, again, what we're seeing is people coming to the table now with a number of possible mechanisms that could contribute to the preservation. And and the way I like to think about it is it's essentially a race against time. Is that things are going to naturally decompose, but if you can somehow encase those materials within a mineral encasement, you are dramatically slowing down, maybe even arresting the decomposition process. So as long as you've got some kind of mechanisms in place that slow down that degradation, you're going to preserve it. And the one way you can slow it down is through cross-linking. So oxygen, which is an oxidative material that will cause oxidative damage to organic materials and break them down, can also drive the cross-linking reactions that then create these polymeric masses that then are going to be resistant to not only to chemical breakdown, but to even microbial attack. And so when you cook food, you get these cross-linking reactions between lipids and proteins and between sugars and proteins. And so in this paper, they argued that could very well be a contributing mechanism under in a heavily oxidative environment. Instead of the oxygen actually driving decomposition, ironically, could drive preservation through this particular mechanism. And once you get these massive polymeric structures, again, they're resistant to microbial degradation, and that's what likely is part. It could be very well be preserved in some systems, right?
Right. And I guess this kind of leads to another point on this whole soft tissue debate in general. With you see young Earth creationists, I know Brian Thomas especially is kind of like the spearhead of this. He talks constantly about these decay experiments where they take collagen and they put it in heated acidic water and they try to get a breakdown equation to predict outwards how long this stuff could last temporally. And I guess the point I like to bring up with this is twofold. There was a 2011 paper. I don't think Mary Schweitzer was the lead author. It was someone else, but she contributed to it, where they were characterizing the collagen found in one of these hadrosaurs. And they noted that a lot of these protein decay experiments ignore the context of the collagen in its actual native state in the bone, which is why they're skeptical of it. And the point that I like to bring up is look at all these mechanisms we're discovering now that these decay experiments didn't take into account. Nobody before was taking into account Mary's iron mechanism or the sugar glycation alternative or this polymerization or other things that seem to be very actual relevant factors. But I guess I'd want to know what you think about these decay experiments in general.
Yeah, this is something else that frustrates me quite a bit because there's a paper that Thomas will cite showing that basically the half-life for collagen decay is at maximum 1 million years. And the particular paper that he studied was work done by a team of archaeologists who were trying to understand at an archaeological site when is it reasonable to begin to try to isolate collagen materials that would be from these fossil remains that would be diagnostic of the particular animal that you're working with. And so what they did is they essentially did an experiment where they had, I don't know, some kind of animal bones that were where they had highly elevated temperatures over this course of 3 months. And what they were showing is that indeed, after about 1 million years, you lose any signature for collagen that would be diagnostic of that particular organism, where you would be using the collagen sequence as a way to identify the organism. But they point out in the next sentence that there's still going to be collagen remaining. It's just not going to be diagnostic. And the fact that they were doing this experiment,
quote line, you say?
Yes. Well, I mean, but they literally quote the paragraph. But if they continued to quote one more sentence, it literally refutes the point.
I have seen that exact thing from Thomas before. There was one
Go ahead, Colton.
There was one paper where they were characterizing, I think, collagen peptide fragments in a mosasaur bone, and they were trying to see whether or not there may have been, it might have been a biofilm. So one of their tests was to look for a post 1950 radiocarbon date, And instead, the only radiocarbon date they got off the bone was on the order of like 33,000 years. And Thomas described this as saying, well, this was despite no evidence of any sort of bacterial contamination leaving the radiocarbon. And his quote was this piece that said, "We could not find any bacteria on the surface of the bone, ... But when you checked the paper, right where he cut it off, it said, despite this, we found clusters of bacteria bored into the bone itself. So bacterial contamination was in fact present. And that makes me, that almost feels insulting, honestly.
Well, it's like
you really care about us that little to not actually at least, you couldn't just address that and say, well, here's why this doesn't account for it. No, you just have to cut it off and tell us it doesn't exist.
Well, it's like the Darwin I quote. They love to cite the first part where he says, oh, I don't know how natural selection could account for this because the eye is so complex. And then literally the next sentence is, well, but if it worked like this, it could certainly account for it. But no, we don't get the second part. We just only get the first part. So Georgia Purdom did the same thing as RJ and I document in The Rocks Were There. She cites an article on beneficial mutations where they say, basically these researchers are doing a review article where part of it is spent asking, what does it mean for a mutation to be beneficial? And so she just quotes this one sentence and says, aha, it's all a word game to them. But then the very next sentence is, here are some examples of beneficial mutations. We don't get that part. So,
yeah, well, in terms of these collagen, decay studies, again, the purpose of the study was essentially to try to come up with a worst case scenario for the preservation of collagen in these remains for archaeological studies, right? And so it was legitimate for these researchers to heat the collagen, at 90 degrees Celsius or whatever, or the bone samples at 90 degrees Celsius to look at the degradation of collagen. But what happens is, and I actually went and looked up, data on the melting curves of collagen, and at above 70 degrees Celsius, collagen begins to unravel. And so it's a worst case scenario where you've got the collagen now unraveled from the triple helix structure. So it's going to be highly susceptible to hydrolysis. Whereas in these fossilized remains, you're not going to be at these high temperatures. And so the collagen is going to remain intact. So you would anticipate that those breakdown studies really are irrelevant to fossil specimens. And again, the point of doing these high temperature studies was to create kind of the worst case scenario, so that as an archaeologist, you would know, is it worth going after a collagen sample in a bone that's 1 million years old? Yes or no, right? They cited the study, but they, again, were not using the study as it was intended, or they neglected the purpose that undergirded the study, when they use it for their purposes.
And I believe when because I went through your book to the best of my ability as I could as a teenager, try to source check you to make sure that I was getting an accurate picture. I was very pleased with what I got, by the way. But I remember reading that paper, and didn't they say something along the lines of, but collagen at lower concentrations would be expected to persist much longer, even under these worst case scenario conditions?
Yes. Yeah. And again, what they were looking at was collagen, the regions of the collagen molecule that would be diagnostic of that particular species. And so there are other regions of the collagen molecule that were likely to persist, but they wouldn't be diagnostic. And I can't remember off the top of my head enough of collagen biochemistry to know which regions are considered diagnostic and which regions are not. But
that's pretty interesting.
Yeah. So, I in a previous lifetime, when I worked in research and development, I did a lot of work looking at stability of samples that we were selling as a company under a variety of different conditions. And one of the things you learn very quickly is that when you do stability studies, you cannot extrapolate the results from one study to another study. Even slight changes in the conditions can radically impact the stability of molecules. sometimes in surprising ways that you would never anticipate. And so what you learn is that when you do stability studies, the results are only applicable to the specific conditions that you're looking at. And so the point being that you can't just simply take a stability study of collagen in bones and then use that to draw some kind of generalized conclusion as to what should or shouldn't survive in under taphonomic conditions. Because if you don't know what those precise conditions are, you cannot tell whether or not that stability is likely or not likely. And so a lot of times when people are trying to figure out mechanistically what's going on in terms of preserving these soft tissue remnants, you really have to be highly specific to that particular system, as you're trying to construct the model for why that material persisted. And so that's why we're really going to be looking at over time a variety of possible mechanisms, some of which will be in play in some circumstances and others in other circumstances, right? And so this is a fascinating area of science, I think, the mechanisms of soft tissue preservation. But it's not just simply a one-size-fits-all explanation. It really is case by case, system by system.
That was always the impression I got, because as another example, whenever they cite like Mary Schweitzer's 2013 thing where she thinks she may have found histones from like the DNA backbone in some of her osteocytes, they like to cite this paper by Alan Toft, like 2012, which was supposed to give a half-life for DNA decay, at least in Moa bones. And young Earth creationists like to run with this paper and say it's been proven that DNA decays at roughly 520, it decays in half every 521 years or so. And I reached out to him personally and I said, hey, is this applicable across like almost all specimens, or is this half-life unique to only the bones you studied? And he said, yeah, it's only for the bones that was under our study. It could be wildly different depending on the conditions at different sites. You have to take it on a case-by-case basis. And it's just a level of nuance that I find, especially a lot of the like lower echelon creationists don't really seem to realize.
Well, yeah,
the young Earth creationists.
I agree with you in that. That's why when we do find the organisms for which we have actual DNA samples are on the order of thousands of years. With Antecessor, it's now 800,000 years, but we still have.
I know there was a horse that was like a horse ancestor that was like 700,000 years, I think, because we have a complete mitochondrial genome from that.
Yeah, there some horses. I think a couple. There's some mammoths, of course, Neanderthals and Denisovans, Antecessor, and a couple of the notoungulates, which were a fascinating group of mammals. But yeah, these are on the order of tens of thousands to hundreds of thousands of years. We're not finding the complete genome of Tyrannosaurus, for instance.
But there was actually a 2019 paper that was basically trying to it just came out like last December, I think, that was trying to basically reinvestigate the possibility of biofilm as a possible. They weren't trying to say, oh, there's no collagen preserved, it's all bacterial, but they were trying to say, look, this is actually a very serious false positive. You have to be careful about it. You have to test it.
I remember that paper. Yeah.
And what they found when they analyzed a bunch of specimens for genuine collagen peptides was that there was a steady, predictable decrease in concentration in collagen the further down in the geologic column they got their sample from. And I don't see young Earth creationists ever bringing that up, because that's a pattern that does not fit their model. If you've got everything being buried in roughly 1 year, if you've got most stuff being buried in mostly 1 year, and then depending on who you talk to, you've got another subset that's buried 300 to 400 years afterwards in all the catastrophes of the post-flood ice age, and then you only have the occasional fossil from past that, it should be pretty similar. That's not enough time to get that cohesive, predictable curve of concentration. So it's just another data point that I never really see discussed, which is sad, because it's one of those interesting things that really tells us what we're looking at here and how to approach this, and it's just never really talked about.
Absolutely, yeah.
Well, I mean, in a sense, the pattern that you are pointing out is, to me, what I think is is really a compelling argument for the antiquity of the Earth from radiometric dating, because you don't have to be an expert in radiometric dating just simply to note that if indeed the Earth really was 3,000, or if the geological record was 3,000 years old, laid down by a global flood, or 6,000 years old because that's the age of the Earth, then you would expect that all the rocks on the Earth would give you, in effect, the same radiometric dates, right?
Yes.
The fact that you're seeing such a wide range of radiometric dates that is consistent regardless of the radioisotope that you're using argues against a young Earth interpretation, right?
Well, it's not just that. It's you've got a consistent pattern throughout the geologic strata that isotopes that are not replenished and have a short half-life are not found on Earth. They're gone.
Yes.
We can only find them in a laboratory or when we manually create them. But it's all the only short-lived isotopes that are ever found anymore are ones that are constantly produced, like carbon-14 being produced in the atmosphere, or like beryllium-10 or something like that.
Yes.
And this is actually a pretty good segue into the whole accelerated nuclear decay thing that they've been championing since like 2001, and the absolute number of problems with that. To start off with, just the heat issue. All the heat that would be given off would make the surface of the Earth, I think, like twice as hot as the sun, I believe is the estimate. And they've admitted that this is a problem that they can only. At first, they said it was, well, there may be some exotic solution, but I've got videos of like John Baumgartner, who also is a proponent of catastrophic plate tectonics, going on record past that in like 2014, saying, "Yeah, we've checked. There is no plausible mechanism, natural mechanism at least, that looks like it can make nuclear decay rates scale up by an order of magnitude. It had to be God's direct intervention. And then you also require God's direct intervention to remove the heat, because they only proposed one natural mechanism for that, which was a sort of cosmic expansion type of thing. And even young Earth creationist Michael Ord noted that, well, if that was the cooling mechanism, the ocean would have frozen solid. And other physicists have noted that if that happened, the sun's external layers would have extinguished. So I don't know about you, but I don't recall the Bible saying that the sun went out during Noah's flood. And on a more serious note, it's very uncomfortable to me how they are continuously now coming out and proposing extra biblical miracles to save their models instead of reconsidering their interpretations of the hermeneutics of Genesis. Because it would be one thing if maybe the Bible said that at the end of the flood, God had to calm the earth because the earth was scorching like the sun or something to that effect, but it doesn't say that. It doesn't say that anywhere. There's no biblical idea here that God cooled the planet off because it was 2 or 3 times as hot as the sun or anything like that. And they even admit, and they're pretty uncomfortable about it. Now, the video I have of Baumgartner, he looks visibly uncomfortable, like saying, as a scientist, I don't like to do this, but it really is the only way we can explain away these physical impossibilities.
Yeah. Well, I mean, it's interesting because I don't have a lot of expertise in radiometric dating, just to be clear. But I have interacted with some of the ICR scientists over the years on some of these issues, or I've been involved in closed door sessions and things where these kinds of issues were discussed. And one of the things that you do see the ICR scientists do acknowledge, and that is that at face value, it really does look like the Earth is billions of years old, right? If you look at the
yeah.
And so to their credit, they acknowledge that this is what it looks like. And so their ultimate appeal is that you've got to have some kind of mechanism for accelerated rates of decay. And I actually was debating a young Earth, John Baumgartner actually years ago about this issue, and it is more of a general discussion of young Earth versus old Earth. But I brought up this whole point that you're relying on changes in the laws of physics, in the constants of physics, and if that's the case, then you should be able to detect those changes in the constants of physics from the light emanating from different objects at different distances away from the Earth. And so if you literally take objects and you start stepping out up to 10,000 years ago and just stop at that point, there's no evidence in any of those objects that you see any kind of signature that would suggest a change in the laws of nature. And, you know, and John Bumgarner's response to me was, well, what you're looking at is essentially with light, an electronic phenomena, and what we're talking about is a nuclear phenomena. And that was his essential response. But that to me just seemed like it was in front of a lay audience, a profound scientific statement, but really it was just this offhanded dismissal that made literally no sense to me. So in other words,
especially when you've got you've got like that supernova from 1987, where we can actually look at its ejecta cloud, and we can see that it's got short-lived isotopes that were produced that are decaying from, I think, 187,000 years ago at the same rate as today. Yes. And as far as I know, the only real response to that is from Jason Lyle and his whole notion where he's trying to say that the speed of light towards the Earth is actually instant. So his way to get around that is to say, well, we're not seeing the light from that far ago. We're seeing that star as it exploded in 1987 because the light got here instantly. But if you read his papers and you actually go through it, he admits that this whole model of his has a big issue with the fact that the further out in the universe you go, the less mature the galaxies start to look. And he has to ultimately rely on this appeal to an appearance of age where God, for example, made these large ejecta plumes coming out of like black holes, which would take on the order of 300,000 years to reach that size. And when it gets to that point, he admits, yeah, God just made it look like this was something that came out of the black hole, but in reality, it was created as is. And there's no reason for that.
Well, you know, what's interesting to me is that this idea that there is a change fundamentally in the laws of nature is actually an idea that runs counter to other biblical passages like Jeremiah 33, where this is a prophecy where Jeremiah is speaking about the certainty of God's promises. And this is to the nation of Israel as it's going into exile, right? Where it looks like the grandeur of Israel is now going to be long forgotten, that its glory is going to be blotted out as the nation is, you know, decimated and they're going into captivity. And you know, here Jeremiah speaking for God is saying to the nation of Israel that my promises to you are as certain as the regularity of the laws of nature, where he's talking about the regularity of the sun going up and going down and you know, the other features of nature that are regular. So here is this statement that the laws of nature are fixed, right? And
which would contradict the idea that God just, for whatever reason, decided, well, if I'm going to judge the entire world, I might as well make physical nuclear processes change, as if that's required to cast a judgment.
Exactly. Yeah, exactly. So this is, you know, theologically, that's rather profound for God to say the certainty of my promises is trustworthy because of the regularity of the laws of nature. Now, there are some scholars who claim that passages like that in Scripture were actually critical for the birth and the flourishing of modern day science coming out of Christian Western Europe. And this is a whole other conversation. And again, I realize that what I'm going to say is a view held by some scholars and disputed by other scholars. So, you know,
I'm probably on your side on this one. Sorry, Jackson.
But the idea here is that from a standpoint of biblical cosmology, the idea is that the expectation is that the laws of nature are regular. And because of that regularity, that forms a philosophical foundation for the natural philosophers that then, you know, gave birth to science.
Sure.
To think that when we study nature, what we see today is going to be applicable tomorrow, and what we saw yesterday will be.
Sure. Yeah. I mean, Charles Lyell and Frick, what's his name? Hutton and everybody else, they were all Christians. So yeah, I'm fine with, yeah, absolutely.
Yeah. So the point is that that this passage is really a significant passage because it is essentially reflects a fundamental idea in the Christian worldview that some people claim was one of those ideas that was critical for the foundation of science. And so this is not a throwaway passage of scripture, is my point. This is not something that can be ignored, and so that you can then speculate that God was changing the laws of physics at the fall or during the flood or during the creation week.
But that is absolutely necessitated by
I mean,
creationism.
yeah,
I mean,
that's what they have to do.
And it's not just, it's, they also even in not just in the chemistry and physics and geology, they do it in biology too. The Jensen's whole idea about created heterozygosity is his way of getting around the fact that there's too much natural variation among humans to be accounted for in 6,000 years. So he says, well, what if Adam and Eve had all the variations and then they just pass those down because miracle, it's the same sort of, well, we can follow natural law up until the point where it totally blows everything we say to smithereens, and we just pepper it with miracles, and then we're fine.
And I suppose my sort of side related point to this is these were the guys who for years were talking about how non-believers really don't have a foundation for the constancy of the laws of nature or how the fine-tuning of the universe, and now they can just throw that under the bus because it goes against their interpretation of Genesis. And this may be a slightly theological point, but as far as I've understood the concept of God, he doesn't seem like he may have ways that you don't understand, but he also doesn't do things pointlessly. And I'm sorry, but changing the laws of physics twice just to account for the young earth worldview, that does seem pretty pointless. If your goal is to judge the world and drown everything except for Noah's family, you don't have to change the laws of physics so that way Noah and everything on the ark can now die of radiation poisoning inside of them and then perform another miracle that you don't talk about to remove that radiation poisoning before it can do any damage. It is a completely pointless ad hoc set of assumptions that are based entirely on, well, our hermeneutics can't be wrong.
Yeah. Well, and to me, I think the thing that is really discouraging is I know of a large number of highly accomplished biblical scholars who would strongly dispute a calendar day interpretation of Genesis 1. I hold to a particular view of Genesis 1 that's called a day age view, but that's just one view of probably 10 to 15 different approaches that people have taken to reading Genesis 1, where these are highly sophisticated scholars that are taking into account the Near Eastern context of those documents. They're taking into account the biblical lexicon. They're taking into account a number of different critical issues in order to develop interpretations of Genesis 1. It's not clear to many people who are scholars what the literary genre of Genesis 1 actually is, where there's a legitimate debate. Is it historical? Is it poetic? Is it a polemic against so the whole point is that the young earth reading of Genesis 1 is a peculiar reading in the sense that it's one among a number of them, a number of readings of Genesis 1 that are brought to the table by highly reputable, skilled scholars, right? So the message of Genesis 1, I think, is very clear, but the actual details of how you read Genesis 1 is actually very complex. And so I think the young earth approach to their hermeneutics and the insistence that this is the only way doesn't really do anybody a service, whether inside or outside the church, in my opinion.
And what's actually funny is that there's a young Earth creationist who's a nuclear physicist named Jay Weil, who would actually agree with you on that. And he thinks that a young Earth interpretation of Genesis is absolutely not clear from the text. And despite being someone that, people like Answers in Genesis could very well use, maybe he'd have some, interesting input here. Maybe he could help out with the next rate project or whatever. They have essentially told him, you're not welcome here because you have compromised on your view of Genesis, even though he's a young Earth creationist
Yeah, I
and
mean,
says that I agree with you on that basis from the evidence, not from scripture. And they still don't want anything to do with him. Ken Ham doesn't like him.
well, Ham has he has personality stuff. He's got personality stuff from what I've seen of his shows. So he's an interesting character, and I think
I don't
it
like the
seems
bad
like
puns, but that's my taste.
it seems like everyone just kind of lets him do it because he has the keys to the place, and they're all just kind of like, haha, yeah.
Yeah.
At least that's what I get from watching Paul's videos. That's what it seems like. At any rate, well, we've been at this for over an hour. Are there any other topics that we want to broach? Well, what do you guys think?
I mean, I've asked the questions that I had. I was really interested in getting your view on the actual decay experiments because that seems to be a technical point that not many people who talk about soft tissue really ever get into. Most of the conversations I see revolving around that are the young Earth creationists will say, "Well, here's the strong science of this," and then the opponent will say, "Well, here's some things these don't take into account." The conversations always piddle out, and there's never any actual technical discussion. So reading your book and your whole thing on that was a breath of fresh air. And what I really liked was how Kevin Anderson tried to call you out for not having like any data to support the Arrhenius breakdown thing. And you posted a thing on Reasons to Believe where it's like, oh yeah, fair enough. But I mean, it took me 2 seconds to find a paper which supported it. So
Yeah.
Yeah, well, that's arguing with creationists for you. So, well, I do want to say thank you guys for coming on. Thank you, Dr. Rana, for returning. I didn't scare you off last time, so I'm glad to have you back.
Well, I'm okay with engaging people that don't agree with me, and I'm okay with having my perspective challenged. It's part of the territory. But my hope is that that we also, as we disagree with one another, can find points of agreement, and just because we don't see eye to eye doesn't mean
Absolutely.
we can't be friends. And by the way, I'm just curious, have you settled on a graduate program?
I am getting close.
Good for you.
Getting close. I've been weighed down with finals, and I finally put in my second to last final. Actually, just kind of before we got on here. So, whew.
So
Fun
Colton,
times.
are you a geology student? What?
Yeah, I'm a student in geology, and I'm about 2 years away from getting my bachelor's. I actually just got the confirmation that I got an AA today, like that passed. So I technically have one degree now, even though it's not all that impressive.
Hey, good for you.
I'm just glad I passed. But yeah, it's really cool because I used to be a young Earth creationist. I was pretty big into the whole flood geology idea, and when I was eventually no longer convinced of that, the interest in geology stuck around, and I figured, well, I might as well make this my career because it's still really cool, and there's still an interesting story here to listen to if you actually pay attention to what the rocks are telling you and don't try to force fit a bunch of extra biblical miracles into the data.
Good.
Yeah, it's they there's a lot of fun stuff that the creationists attempt to do, all of which you can read about in our new book, The Rocks Were There.
Great book, I like it.
Thank you. Yeah. Oh boy, the whole Kurt Wise's whole floating forest thing just gets me real good. Have you heard of that one, Dr. Ross?
No, I haven't.
Oh, that's
During the
whole
flood,
thing.
there were floating forests, and the entirety of he basically says, yes, the Paleozoic sequence is consistent with an old Earth, but it could also be that the organisms on the forests or in the forest just happen to be sort of zonally segregated so that when it crashed onto land and they all got buried, it just looks like different ages. It's gravy.
One of the things that really annoys me when I hear it was the fossil sorting mechanism of like ecological zonation, where the things are buried by different habitats, and that would explain the sequence. And the question I always bring up is like, okay, well, that seems like it's pretty easy to test. I would imagine that, fossil cetaceans like Dorodon and Basilosaurus probably shared a very similar environment to mosasaurs and other marine reptiles. Wouldn't they have been buried at the same horizon in the stratigraphic record then? Well, it turns out I always get accused of strawmanning here, but I'm not, because Ariel Roth and the Geoscience Research Institute have admitted this is a problem. And their solution is to propose that there were separated different seas at different elevations. So that way, as the global flood rose up over the land, there would be an ocean near the bottom where all the trilobites and everything are. And then there would be land systems. And then there would be an elevated ocean where the marine reptiles are. And then those get buried in a separate sequence. And then it raises more to another set of inland oceans that are at a higher elevation where the fossil whales would have been. And they actually have pictures of this, and it's like, why? We have no evidence this is even possible. And you're just adjusting the pre-flood world to save a mechanism that clearly isn't working. That just bothers me. The idea of isolated, segregated inland seas at different elevations, just wow. You okay, Jackson? Uh-oh, did we lose him?
I think Jackson is frozen.
Yeah.
Oh, there we go.
Can you hear me?
Yep.
Yeah.
Okay, my internet's starting to die, so we might as well drill for it. Totally cuts off. Thank you guys again for coming. Thank you, Colton. Thank you, Dr. Rana. Thank you, everyone, for watching. And thank you, Peter, for hosting my stream again. I very much appreciate it. My internet is totally garbage.
You're welcome.
So, thanks, everyone, and we'll see you next time.